Okay, I think I'm going to just start. Hi, hello. My name is Almir, and I'm going to tell you a story about F# and Azure Functions in production. But first, a little bit about myself. I'm a consultant at Fosse, currently working for NRK, or more precisely NRK TV. For those of you not familiar with NRK, it's the Norwegian Broadcasting Corporation, the BBC equivalent, if you will. So this is how the streaming service looks like. And currently I'm working on the playback related APIs, but today we're going to talk about a different API, and it's called Headliners API. So the question is, what is it? Well, it's an API whose main purpose is to display the most watched content the past week. So what you're seeing here is a screenshot from Android TV. So this is in the system menu. So before you actually open the application itself, you get teased content, so to speak. Another client is Chromecast. So before you actually play any content, you get a slideshow of the most watched content. And similarly, we have it at on Apple TV as well. And hopefully we are going to get smart TV on board as well. So as the title suggested initially, we did a total rewrite of an existing system. So the question is, why did we do so? Well, first thing is we saw that there was a need for an architectural redesign. We thought that the initial implementation was a bit too naive, like any systems tend to be at the first attempt. I won't go into the details, but just to summarize, it was enough to make us redesign the entire system. And secondly, it was a great opportunity to try something different. And I want to emphasize different and not new, because new is basically every second, especially in the industry we work in. Historically speaking, I'm a C# object-oriented developer, but recently I've been become really fan of F# and the functional movement. So in addition to trying out a new language, we also saw an opportunity to try and go fully serverless as well. So if we go back to the scope of the system, it's all about displaying the most watched content the past week, nothing too fancy or complicated. The source of this list is based on the recommendation API and is updated once daily. Content within this list is either a program or a series with metadata such as images, titles, and usage rights. The source of the metadata is the catalog API. And lastly, we have a premise for a system, and that is that the content without any usage rights must not be displayed. And the reason for that is simply content without usage rights is not playable. So in some cases, it can actually do more damage than good. So if we list the technical stack for the system, as the title suggests, F# all the way. Azure Functions all the way. We used many of the bindings and triggers. We used Azure Storage, all the variants, so blob, table, and queue. Azure DevOps for build and deploy, and Expecto for testing. So yeah, that's your equivalent NUnit, XUnit framework. So if we zoom out on a more technical architectural level, I guess the topmost level, we have the workflow where we do both the reads and the writes. And then we have the API itself, which is a purely read API. So if we zoom in on the publishing part and look at the leftmost Azure function, we have something we call the recommendation importer function. And as you can see, it is triggered on time. So around midnight, we go to recommendation API, fetch a set of IDs. So that is series IDs or a program ID, store it in the blob. And then we have another function called catalog fetcher function. It's triggered based on a message on a queue. So we send the set of IDs to the catalog fetcher function and then fetch the necessary metadata for each and every content ID. This is again then stored in the catalog table. So in order to keep the data updated, we use a catalog change listener, and this is triggered on a topic. So we listen to events, and if that particular ID matches the ID we have stored in the recommendation blob, we send an update message to the catalog fetcher function, which then refreshes the metadata. And then lastly, we have a headliner publisher function, which is triggered based on the catalog fetcher function, which then uses the set of IDs combined with the metadata in order to create the response in the what we call the headliners blob. That is the workflow. Let's look on the API. The API is composed of two Azure functions, HTTP triggered, one in each region, North Europe and West Europe. And since we use geo-redundant blob storage, we can pinpoint the respective location of the where to read the blobs from. And in front of the APIs, we have a gateway composed of Nginx and Varnish, both of routing and caching. And as you can tell from the path, this system actually is composed of or works for TV and radio. Yeah, that is more or less the system architecture, but what about performance? Let's look at some metrics. So the numbers I'm going to show you now is based on numbers from the entire month of May. So if we look on a transaction, and a transaction is defined as a read or a write on an entity. So in this case, it's a blob. So we had 5 million blob transactions, 1 million queue transactions, and then 24,000 table transactions. If we look on execution is basically a unit of work in the Azure function jargon or sphere, if so to speak. Yeah, so we had 456,000 executions on the publishing side and 1 million API executions. But I guess the most important thing is what actually affects the users, and that's the response time. So we had 20 milliseconds average response time in the month of May, which I consider to be quite good. So I don't usually talk about cost, but I think this is really interesting to mention because throughout the month of May, based on the metrics I previously showed you, this cost us 59 kroners. That is like $6.3 more or less. And to put that in perspective, that's like a half a kilo of ecological sweet potato from Portugal. Maybe you can even get a kilo other places around the world. So yeah, I would consider it to be quite cheap. And lastly, I just want to show a quick example of how you can use F# in such manner to express your domain. So let's look at a domain-specific rule. We have a domain-specific rule saying that any content has usage rights from or to a particular date and time between a period, or it's perpetual. So for those who are not familiar with the word, perpetual just means that the content is set to have indefinite usage rights indefinitely. So this is typically content that NRK produces self, so News or even the TV show Scum, if you're familiar with that. So if we look at a concrete example how we express this using the algebraic types in F#, so this is a union type, or also commonly known as a choice type. So you can choose between the sets, between, until, since, and then perpetual. And within the different types, you can see which data is encompassed. And in perpetual, we don't have any data because we know how to handle it. So just to show a quick example how this is used, we have a function that checks the usage rights. So we have two parameters, the time now and the usage right. So we add some buffer of 48 hours just to take into account if the system goes out of sync. We evaluate the different usage rights, and then we check whether if it has usage rights. And you can see for perpetual, it's set to be true, always true. I think this was a nice example of how you can express the domain using F#. Yes, and just to quickly summarize, events and commands using together with F# and Azure Functions, I think it works really nicely. And this notion of having this unidirectional workflow, it seems to be working really nicely together. Secondly, this may look like an advertisement, but I think using all these together works really nice. But if there's one thing I want you to leave with this from this presentation is hopefully I've inspired you to try something different and yeah, at least maybe try F# because that has really changed the way I think about programming. And yes, that's about it. Thank you.